Hello, today we're going to be talking about radiation safety basics. We have a number of objectives to cover today. We're going to take a look at the components of an atom, the types of ionizing radiation. We're going to also take a look at several concepts, and then we're going to identify hazards, look at employer requirements to protect you against those hazards, and individual best practices. A little bit about myself. I'm a radiological officer for a regional hazmat team. I'm an instructor for the Department of Energy, and I also co-founded a nonprofit that works inside the Chernobyl exclusion zone. Little science here. All matter is made up of atoms, tables, chairs, and ourselves. And inside each atom, we have protons, neutrons, and electrons. Now, not all atoms are stable. And today we're going to be talking about those unstable atoms because they are radioactive. Another thing to differentiate here is we're going to be discussing ionizing radiation. If we look at the electromagnetic spectrum, you might recognize certain things: radio waves, ultraviolet rays to get your suntan, and even x-rays when you go to the doctor. To the right of this high energy part of the spectrum is what actually ionizes. And what ionization is energy that has enough momentum to disrupt and strip an electron from an atom. And that's what makes it hazardous. There are four basic types of ionizing radiation: alpha, beta, gamma, and neutron. You may have heard of these before. Alpha radiation is very large, relatively, and it has a positive charge. A lot of energy, but it only travels a short distance. It can be shielded by air, even a piece of paper, or the dead layer of skin you have. It doesn't represent any external threat whatsoever, but if you were to get it inside you, it could be very hazardous. Beta radiation is slightly smaller, and it can travel farther than alpha. It can also penetrate human tissue, up to about 1/4 of an inch. But it's also easily shielded by plastic, aluminum, or even maybe 5 or 10 feet. It is an external hazard, but internally it's less of a hazard than alpha. Gamma radiation has no charge. It's just pure electromagnetic energy, and it travels at the speed of light. It's highly penetrating. It's a whole body hazard, external and internal, but the good news is we can easily detect it. Neutron radiation is not commonly encountered, but it is something we do have to briefly discuss. It can also travel great distances, but it's very hard to detect because it is neutral. It has no charge. Radioactive decay. Any radioactive material is constantly emitting radiation, and as such, it's also decreasing the amount of radiation that it has. We measure that as a half-life. It's half the time it takes radioactive atoms to decay into another form. Now, each isotope, you can see here this column that says isotope, nitrogen, cobalt, americium, they all have different half-lives, and those can be used for good, such as medical isotopes, as technetium-99. It's used for diagnostic procedures, or americium-241 that's used in your smoke detectors. After 10 half-lives, the product is essentially gone. Now, radioactive contamination, another important concept. It's radioactive material in an unwanted place. It could be on the ground, it could be in the water, it could be on you, or worse, it could be in you. We have to understand the concept of exposure versus contamination. Take a look at this drum. If you walk up to it, you would be exposed to the radiation that's being emitted from that drum. Now, if that drum was turned over and the contents spilled out, it would be contaminating the ground because those materials are in an unwanted place. Furthermore, if you went up and touched one of those suits and got it on your hands, you would be contaminated. And then in an even worse case, if you touched your fingers to your face and ingested that contamination, you would then be internally contaminated. Let's talk about some of the hazards. An acute dose of radiation can result in severe injury or even death. Now, this is very, very rare and not something to be overly concerned about. There are a lot of protections in place to prevent you from getting an acute dose. Now, a chronic dose is something you would get over time at a much lower rate, but it could lead to cancer. This is something that is debatable. Take a look and you'll find studies that are pro and con in this area. Now, as a radiation worker, there are federal standards and laws that provide exposure limits. And for a radiation worker in the United States, the annual exposure limit for your whole body is 5 rem. Rem is a measurement, and it's something we could go into at a later date. Now, you will be required by your employer to wear a dosimeter, similar to what you see here on the right, to track your exposure, and you'll turn that in on a regular basis and get a report. Now, working in a fixed facility, the Nuclear Regulatory Commission requires employers to post signs in radiation areas. And you can see as it goes to the right, there would be a higher amount of radiation and a higher potential for danger working in those areas. And this also regulates how much time you can spend in each area. In addition to NRC regulations, OSHA 1910-1096 also provides requirements for employers. Now, lastly, in the what's in it for me or takeaway from this presentation, out of anything, if you ever see this red triangle symbol, it means you have gone too close to a very large and very dangerous lethal source of radiation. If you see this, run away. Protection. The industry best practice is to use ALARA, or to keep exposure as low as reasonably achievable. How do we do this? We use time, distance, and shielding. The less time we spend near a source, the less radiation we receive. The further away from a source we are, the less we receive. And if we can put anything between us and the source, we can also reduce that. Okay, we've talked about the 4 types of ionizing radiation. We've talked a little bit about science and atoms, also about decay and half-life. We've understood the concept of exposure versus contamination, and we've identified acute and chronic hazards. We talked a little bit about dosimetry, as well as signage you may encounter in a fixed facility, and we talked about concepts of ALARA, time, distance, and shielding. Thank you.